Hey guys, how's everything going? This is JSer. Even though I am a front-end developer, but it never hurts if we know beyond front-end, right? Yeah, I guess if we are going to take more responsibility, it's better we learn more about backend, native, stuff like that, architecture stuff related. So today I'm going to introduce you something I learned recently. It's called columnar. What is that? Column oriented DBMS. There's a word for it. Columnar. Columnar. Okay. Yeah. Why I noticed this is that recently, yeah, I heard about ClickHouse. It's something interesting. I'm not sure what your company handles those big large chunk of data, like allows you to query for the metrics, something like that. But this ClickHouse is often, yeah, it's kind of the solution like that to provide you with those data analytics storage and query tools. It's called online analytics platform, something like that, maybe. Yeah. So it is not it is not like simply okay, I add a database and just a existing database solution. It's using the column oriented database under the hood. So yeah, in this video I'm going to read out through the Wikipedia. You can search this on Wikipedia by yourself, but I'm trying to introduce you to check if I understand it correctly. Like one day, if I am being asked an interview, say, "Hey, do you know about column-oriented database?" Something like that. It would be super helpful for me. So for I think for the row-oriented database, I think everyone is already familiar. It's traditional. It's robust. Like currently, I think most of the time we're using it, even though there are some NoSQL solutions. But generally, this kind of a row-based solution is what we have and where we're used to it. Yeah, there for each row, and each row have different field. Like for the example here, this is the ID for the row. Basically, we are using incremented number, right? Integer for the row ID, and then for each field, we have different values. There are different data types like string, integer, and also recently we have some JSON, something like that. But generally the row is the basic unit. So for each row, it's basic data unit, and for that unit, we have different properties, which is the field. So internally, for the row-oriented systems, we could we can picture it like this. It's basically we store the data together with each row. So the properties for these fields, they are bound to the same row. So the data internally, no matter what you're storing, they are stored together. This is why internally it's also row based. For each row, it means a row in a database. So here, like, this is the simplified example. It must be more complicated than this, but basically, yeah, each row in the database maps to each row in a real storage, internal storage. And this means that if we're going to query some different fields, different properties on same row, it's gonna be very performant because the data are already in the row, in one row. So suppose you have a cursor. If you want to search for the different fields, they are close to each other, so we don't need to move around. So this is why, and it's easier to understand, right? And this becomes a problem like if we have like big volume data, like for the analytics, like you're tracking users clicks, page visits, something like that. It's a huge chunk of data, and if you're gonna store in a row like this, when you're queried, what you actually query is actually you're querying like for same like a few part of the properties, part of the fields, right? Like okay, for salaries, maybe you want to query something. Okay, give me the average salary for all the users. then if we're doing the row based, we need to actually jump on all the different rows to get the data for the salary, right? Like, okay, we need to scan through the first row to get to the number, scan through the second row, get to the number, and yeah, that's pretty rough. It means that basically, if you want to do something aggregation on the same column, which is a field, it basically needs to traverse through all the storage. That's why people are creating this column-oriented system. So basically, rather than we store the piece of data by row, we store it by columns. Meaning, like we can store each column in a row. So for the example here, this is row ID. We could store this column in a row, and meaning, okay, the first one is. Oh, I'm sorry. The first one is the index row ID. So let's skip it and look at the employee ID here. It means that, okay, it means the first row, its employee ID is 10, and then second one is 12, and third one is 11, the fourth one is 22. So which means that this column will be put in a row, this last name will be put in a row. This first name will be put in a row, and the salary will be put in a row. So if we imagine the same situation, we want to get the average salary. Now, what are we gonna have? We have all the data in the same row. So we don't need to jump back and forth, left and right, jump everywhere, because all the data are put in the same place. And by this, we mean it's super performant that we can do some analytics to a few rows. So this is why it says that it's very useful for OLAP. It's called the online analytical processing. Oh shit, it's OLAP. It's not online analytics platform, something like that. I'm sorry. It's online analytical processing, and the other one is online transaction processing. This means that you need to store some I don't know, the intermediate steps of the transaction. It's more about a write. It's not more about it's not like analytical processing. This is more about the read, because those analytics data seldom changes, right? But transactional, for the DBMS, traditional DBMS, we have this concept of transaction. We need to make the data consistent. If it fails, we have some rollback mechanism. So we need to make it right? But for analytical, we care more about performance. Also, it's more performant when we have the sparse rows. For example, when we have an analytics needs, we often have a huge amount of fields, right? But in a real application, those fields might be null based on where you want to log. So for most of the time, the fields are sparse, meaning part of the table like this will be empty. This is pretty common. I met this a case in our company's analytics platform. But for that case, if we do it in the row base, most of the fields will be empty, right, and scattered around. But if we do it in a column based, those just skipped. And basically there's no such thing as null. It will help reduce the storage. But for row based, we need to. It's kind of like a placeholder. We need to save the space for the possible value there. So yeah, this is the basic. There's a part of one piece of picture I am missing is that for row-oriented systems, we are familiar with the concept of index, right? If you want to go to search something, like search a row by specific field value, say, okay, I'm going to get all the users with a salary of 80,000. we actually need to set up an index for this salary. Otherwise, because it's not pre-calculated for the data structure, we need to go through all the table again and get to the users by comparing them. So it's not very performant. That's why we need to add the indices. And basically, the indices, it's pretty familiar with. It's pretty similar to what we're doing in the column argument systems. If you look at this, you can see that it's basically, sort of indices, but they're not 100% exact. It's not exactly the same, but the idea is common. So this is really interesting. I hope in the future, we are talking about database. You can share your knowledge about this column-oriented DBMS. I think nowadays, for larger and larger applications, analytics need is gonna be huge. Especially we know something about that. Cool. This is it. Webner DBMS. Pretty cool. See you next time. Bye bye.